This is tutorial 4A, question 1b. In this question, it asks us to interpret this equation. What does this equation do? This equation actually is the inner product of two functions of f and g. So basically, we are asking this equation to compute the signal f times the signal g across time a to b and sum it up. So basically we are forming a new signal f times g, and we are finding the area of this signal between a and b. Now, the inner product of two functions basically tells us how one function, in this example, how f is related to g. So in our case, we are examining how f is related to e minus st for different value of s. And we are asking ourselves the question, for the whole of complex plane or all different e minus st that we can generate, how is ft related to e minus st? And we have seen what is e minus st for one example here. So basically we are multiplying ft by a complex exponential and many different types of complex exponential. Now, if the value of the inner product is equals to 0, then this is called the signal f of t is orthogonal to e minus st. When that happens, it basically means that f of t and g of t are perpendicular to each other in that dimension, and one of the functions cannot be explained by the other. Now, the other interpretation is that why are we measuring, or why are we changing f of t to f of s? Basically is we are trying to represent f of t with different f of s. That's one interpretation. And because of that, different f of t will result in different f of s. And when the signal is causal, f of s is unique. And when f of s is unique, then we can go from f of s back to f of t. And why do we want to do that? It's because the signal represented in f of s has certain properties, especially for differential equations where differentiation becomes much easier to handle. For references, you can look at this. But maybe the take-home message is simply that when we convert f of t into f of s, it is simply multiplying the signal f of t by e minus st for all of s. And this basically is asking us to measure f of t using different e minus st. And when we measure at different e minus st, which is the inner product, the resultant f of s has nice properties which we exploit. That's all. Thank you.